everyone's here to solve the question I created on Instagram. So let's get started. This question is geometry really, but you need to know a bit about quadratics and functions. We need to start with what we know. So we've got given a few facts, but the first thing to realize is we only know one piece of real information, which is this 4 down here. Now this equation up the top here, this links all of the coordinates on the green line on the quadratic. So if we have a point on that quadratic, we can use it to find an x if we have a y, or find a y if we have an x. It's like a gateway, like a converter. So be aware of that as why we might use it. The other thing to know is if we have a value of x, like we do here, 4, as you can see there, it's on the x-axis, then if we put that into the function, what will come out is the corresponding y value. So let's go ahead and do that first. Okay, so we put the 4 in, and I've been careful to use brackets. Next, we're going to try and work some of those through using a calculator. Let's tidy up these fractions. Probably best at this point to put it into a calculator. What we can do is put that on the diagram. So what have we found? Well, we've now found a new bit of information, the 20. What does it mean geometrically? It's this length here. So the height of one of those congruent rectangles is 20. We can see another point that we're interested in here, W. This point here is made up of 2 of those rectangles. So this point, we know something about it. We don't know the x, but what we do know is there's a height of 40. So this is where we use our converter. We have a y this time. We're just going to put in what we know about y, and using a few skills we may have picked up along the years, we put that in and get the x value. We'll say that if you have the y, it's harder to get the x because there's 2 of them. I'm just going to draw a line underneath the old work now, and we're going to put this equal to 40. So the difference here is we're finding x, and there's so many x's here, we need to employ methodologies. You can see the highest order is 2. That makes this a quadratic. And for a quadratic, we have our preferred layout, which is getting them all to one side, put it equal to 0, and making the x squared term positive and as simplified as possible. So what would that look like? My first call is to multiply everything by 15. Can you see why? That fraction is not the best thing, is it? Just a little calculation will reveal that we've got 600. If we're going to multiply this fraction by 15, it cancels out the denominator. I think a lot of people will forget to multiply the 4 right here. It's actually important. And the last one. Okay, much better now that we've multiplied by 15. And I'm a big fan of having the x squared positive, so I'm going to go ahead and move that across. But while I'm doing it, I'm going to move them all across. Now, because there is a 1 in front of x squared, it's not really anything for us to do about cancelling this down. Methodologies for you to solve this quadratic are vast. You could do complete the square, you could use the formula. Let's just say we put it into the quadratic formula. First one is 54, and the second one is 10. Now, we can talk about, which one of these is likely to be the one that we need. So let's say this is our quadratic, and we're currently focused in on the left-hand side, which is here. And what we know about this little side that we're working on is that this one here is 4, and the part that we just tried to look up is around here, like this. So we're thinking about our solutions for when this height has been reached. So we have two. We have one which is on the left-hand side, a smaller one, smaller value of x, and one that's on the right-hand side. If we were to assign these two, it would be only logical to say that this one on the right-hand side is 54, and the one on the left is 10. So we can say that the bottom of W has probably got an x value of 10. It's not probably, it's quite conclusive now. Getting there, there's one last step, just one. And because we know that this is 10, we know that the distance between these congruent rectangles, which is this here, is 6. So if we go along another 6, we'll get to B. So finally, we find that B is equal to 16. If you enjoyed going through this problem, it would be great if you hit the subscribe button and stick around for more content just like this. And if you really like this video, please hit the like button, because that lets me know that you like the content and want to see more of it. On top of that, if you feel really passionate and you want to reach out for a question or a topic, just leave a comment in the comment section and I will read it and respond.